Hello, everyone, and welcome to today's webinar. Thank you for joining us. We have a presentation and on exploring what's new in Creo 7.0. My name is Alex Janicki. I'm Director of Marketing for TriStar, and I'm excited to be hosting today's session. I'm pleased to introduce today's speaker, Technical Pre-Sales Specialist Paul Dye from the PTC Virtual Center of Excellence. And before I hand the mic over to Paul, I just wanted to mention that this webinar will be recorded and sent automatically to everyone who registered and available on demand. We would also love to hear from you during today's presentation. If you have any questions for the speaker, please feel free to submit them into the chat, and we'll be answering them towards the end of the session. So without further ado, I'd like to kick things off by welcoming our presenter, Paul Dye. So Paul, over to you.
All right, thank you very much. Again, like Alex mentioned, my name is Paul Dye. I'm an application engineer here out of our Virtual Center of Excellence with PTC. And we're here today just to go over the general question, really what's new in Creo 7.0. There's a ton of new stuff. Obviously, this is actually one of our major releases, and around this is more than I could cover in just 30 minutes to 45 minutes, an hour even. So we're going to hit on a lot of the main points, maybe some things around core modeling, some things around different applications, some of the different extensions. I'll go through and show a demonstration of one of these extensions in the context of Creo, so you can see, just get a feel for what we're working with here, and then we move forward. And of course, like Alex mentioned, any questions that you have, feel free to drop them in the box in the Q&A, and we can answer them after the presentation. And if you do have anything that you think of after the call, feel free to reach out with those as well, and we can get some answers to that. So diving in, first we're going to look into really our first section here with core modeling. And first we have improvements to the import data doctor. So that's really important if you're working with non-native geometry. We now have support for MultiBody. And there's also a troubleshooter in this import data doctor, looking for things like open quilts, surfaces, and how we find and also fix those. We also have new display filters for geometry representations. So whenever you're showing off these different representations, we've improved your ability to show off different features. So for example, here, if you wanted to highlight on these lattices we created, but have the rest of it be translucent, there's a lot of options around that and really display off these different features, which is especially helpful if you're working with things like multi-body. There's also been enhancements to the draft feature, things like drafting already drafted surfaces. You have the ability to detect existing draft angles in the model. So it makes it a lot easier to work with and then go through and modify later on if you need to. And also improvements to the performance of snapping to model geometry or to a grid. So it's really, you have full control over it now. So you can quick menu very easily switch that on or off. So depending on what you're working on, you might want to quick snap to geometry or lines or edges or simply to a grid, really build it out the way you want. Made enhancements to the mirror tool in the sketcher. So it makes it very easy to grab things in mirror. Now you can essentially grab any street sketch and use that to mirror about. And once you move that around, the mirror tool is either going to update or not, depending on how you have that set. Another enhancements really been made to the visualization of your design intent in the sketcher. So we've improved the look of how those relation icons look, the ability to highlight references, change colors. It's really overall modernizing the look and the feel to work better in the sketcher and to really understand exactly the different components in your sketch. And also in the edit dimension selection, you're able to set the appearance of your sketcher constraints. So when you click to edit those dimensions, also show the constraints, that's just another config option that you can activate there. So just a couple quick looks over the core modeling enhancements we made, but now I want to get into more of the applications and the extensions. So first starting in here with Creo Simulation Live, aka CSL. And if you haven't worked with this before or haven't used it or haven't even seen it in the past, this is a tool that we developed as part of our partnership with ANSYS to put real-time simulation right within the modeling environment. This is something that we've been building out for a couple of years now, something that ANSYS has been working on for longer than that, something that we've really made improvements to and enhanced now our ability to work going forward with Creo 7. The first thing that we've done is add the ability to control the direction vector from a selection. So it doesn't just have to be a default. You can actually select right on the model, just on a face or an edge or whatever you're applying a constraint or a load to, and it simply defines all the directions for you. And building off of that, you now aren't locked to working with the overall global coordinate system. So you can define everything from a selection of coordinate systems. So if you have one defined, you can use that to build out your load cases. That's improving just the general ability to define those loads, or the constraints at the start of the study. We also made enhancements to the legend, so specifying what you want to look at, how those values are displayed, especially whenever you're doing things like setting the upper and lower bounds for the values that you're displaying, where we have these composite views where you're essentially only displaying values within a certain range on the legend. So here, if you only wanted to display between 0.03 to 0.013, you can simply just drag those up and down, and then right on the model, the view that you're getting is only showing the values if they're within that range. So very useful there, very easy to work with. And we can also use values that we get from our simulation probes in CSL over in our behavior modeling studies. And what behavior modeling allows us to do in Creo is take values like if you're getting your von Mises stress or displacement in certain areas, you can actually start to optimize around it. Where with behavior modeling, which is just a core functionality of Creo now, we're just taking kind of different dimensions that you can change, different variables that the system's allowed to use. And what it does is automatically optimizes the model for you based on whatever you've allowed it to change for different design goals. So it's a very useful way of using the analysis results we're getting from CSL. On top of this, we've added more real-world constraint types, things like ball, pin, planar constraints. It's helping me to make each of those cases that we're building out more realistic to the problem or the situation that you're trying to design around. And CSL also now has support for multi-body design. And there's a ton of different applications of that, things like cavities, internal, external volumes, fluid domains, that kind of thing. And so on top of that, we also have specifically to thermal studies is the ability to do transient studies, aka time-dependent analysis. So it allows you to see how your results are changing over the course of time. So now in that thermal setting, either do it steady state or do it as a time-dependent and check different points in time. And then probably the biggest change to CSL is the option to do flow analysis now in the same way that we do for structural, thermal, and modal cases, where we're essentially starting into the study by creating a fluid domain, where we're telling the model essentially which areas to include. And we can go through and define the inlets, the outlets, the initial temperatures, velocities, that kind of thing. We also specify the materials for those fluid domains, and from there, visualize it right on top of the model that we're working with. And that's the idea, is really regardless of whether it's an internal or an external case, be able to visualize and work with it right within the model environment. And along with that, a lot of different options for really visualizing the results that you're getting. Visualize the streamlines, particles, taking section views, direction fields, setting probes. It's really a powerful and at the same time, easy to use tool for doing that type of flow analysis. Where normally, if you're a designer and you wanted to work with this, it's either completely out of your realm or just too expensive to really start to implement. Or normally something that if we want to get any type of flow analysis done, we'll ship it off to the analyst, maybe get results back by next week or hopefully by the end of the week. None of that. We simply just take the design that we're working with and simply take it into CSL flow analysis and see what we're working with and really get those type of results right as soon as you go through and define it. So we'll go through and take a look at that. I will go through and show a demonstration of how we work with Creo Simulation Live flow analysis towards the end. But one of the other big enhancements that we've had in Creo is really the ability to work with multi-body design. So it's really offering a new way to design in Creo, where if you haven't worked with multi-body design, it's really a methodology that allows you to be flexible in the way that you design your parts and the rest of your model, I guess. Where these bodies, each of them can be handled differently. You can apply different materials, included or excluded in your mass calculations, how you define your global interferences or clearances, and many other options around this. So it's something that's going to be supported mostly everywhere in Creo going forward. So a lot of applications are going to be able to work with this and get a lot of good use out of multi-body. Those bodies that you create are going to be an entirely new object type in Creo. They still appear right in the model tree under a bodies tab. And each of those bodies can have their own individual appearances, parameters, attributes, and with each of those, we can have different operators for working with that geometry. That means merging, subtracting, intersecting, and once you've done what you need to do, you can make part files out of any of those bodies. So really, this is a powerful way to work. And if you never work with MultiBody, it's definitely something that you're going to want to try out. For some people, the standard way that we're used to working in Creo is going to work just fine. It's still an awesome way to work. But for many people, this type of Boolean work where you're doing merging and subtracting bodies, it's going to open up a new world of possibilities and just a new kind of multi-body design approach. You can get there much faster for some geometry as opposed to maybe working with typical surfacing or quilt-based workflows. So definitely something to keep in mind and something to check out. And then one of the biggest really developments with the release of Creo is then in the introduction of generative topology optimization. The generative design, if you haven't seen this, it's autonomously creating optimal designs from a set of design requirements that you lay out for your study. And so working with this in Creo, you're going to be able to specify things like your requirements and your goals that you want to work towards. And the generative engine automatically produces a manufacturable design, either as a start point or even as a final solution. And so it allows you to try different materials, physics, manufacturing constraints, automatically create that geometry. What that allows us to do is try out many different generative design studies. So you can start to explore all kinds of new design alternatives. And then once you go through those, compare the results you're getting between each of those to start to work towards more the optimized design. Around that, you're able to visualize real-time all that generation. So even as we go back, modify that input geometry, the design criteria we want to work towards, just go ahead, click to run, and we can see it real-time what it's creating for us. What that process allows us to do is interrogate and start to review the analysis results. We can check out what our stress values are going to be, what's the deformation, and as soon as you start to get those results, go back and change things. Change those design constraints, any of the geometry, try out different materials, and see what that does to the model and what kind of geometry that you're getting back. And we're able to do all of this because it's integrated right in Creo. We've integrated this Frustum technology right into the modeling environment. It's not some separate window or another software we have to switch over to and import, export, all that. No. All we do is define the geometry, tell the system what we can change, what things that we can't change, any constraints, and just let the system go. And once the system generates that design and you've had the chance to review it, you can go ahead and output the results to use elsewhere in Creo for further refinement and optimization. So if we're going to do that, we're able to take that design and convert it into solid B-rep geometry. So in that process, we have different options for how the model is reconstructed. And then you can go back and forth between the two to kind of see what's changed and really do that to get the best model possible with still manufacturable geometry. And that's the idea here, is we're not just creating these tessellated files that are nice to look at. These are things that are curvature continuous and actually can be manufactured out in the real world. So a big advancement there, but also enhancements around some of the things that we've been building out over the past couple of releases of Creo, such as in the world of additive manufacturing and 3D printing. And the first thing here is with the creation of stochastic lattices. This is something that we've enhanced the way that the lattice type follows along some of these hard edges on the outside of our parts. So it makes those structures even more structurally sound. So we've seen a ton of really cool uses for this in a lot of really use cases in the medical field where you're kind of creating bone grafts, that sort of thing. So these stochastic lattices have some really interesting uses around that. And also improvements to custom lattice cells. And what that is really when you're taking a part file that you have in Creo and using that as the cell for the lattice. In the past, we've had the option for full geometry, but now we've also included an option for a more simplified B-rep geometry as well, which is helpful if you're creating lattice structures that have tens or hundreds of thousands of these. You can create more of a simplified B-rep to help that propagate a little bit better. And then specific to the additive manufacturing plus, around mainly when you're printing with metal instead of just plastic or anything around that, we've made improvements to the tray assembly definition. That's really utilizing the MultiBody Design methodology. Even within the same part file, you can have different bodies with different parameters, wall thickness, colors. There's a lot of uses around that, working with that there. And the opposite side of it, instead of additive, you might be also working with subtractive manufacturing. So over in the world of machining, we first now can view synchronized tool paths right in the graphics area. So we've always been able to synchronize those tool paths, but now there's a synchronization menu where you can actually highlight what you want to see, you can view them, and it helps you keep track of it. And here we have, again, we've always had kind of go home commands, but now some machines need multiple go home positions. So especially if you have things like mill turn operations, you can have multiple go home positions, home 1, home 2, home 3, whatever you need with this. And finally, the ability to explicitly call out Swiss turning operations. So if you have a mill turn machine, you can fix the Z-axis and put all the appropriate CL commands into that output file. So that's a function of our complete machining suite of tools. If you work with that, it's definitely a breath of fresh air to work with Swiss turning. Right. So moving on here, another big focus has been around specifically the work that we do with detailing and model-based definition, where a lot of companies are really starting to move towards this way of working with the drawing information, the dimensioning, GD&T, and doing that right on the models themselves, but also still working with the 2D and working with those drawing files, so that's something that you do as well. So first, of course, we've included multi-body support in our drawings. So if you have different bodies with different materials, even if they're in the same part, you can go ahead and make those cross hatchings look different. You can differentiate them a bit better there. Also have the ability to repeat regions in the drawings for those multi-body parts. So exclude certain bodies, include that all in your tables if you want to. And then over in the drawing model tree, we can have control of those different bodies where we can identify them, hide them, and just helps us keep it all straight. Here we have the ability to configure drawing view tooltips. So what that does is if you click on the view, you can kind of see what the part is, the model, the combination, or the explode state. And we also have a new summary view command where we can click on an element and have the system kind of tell me about it. That's a really good way to understand the design intent that went into these drawings, especially if it's something that you haven't worked on in a while, or maybe you weren't even the one that created the model itself. It's very easy to reference back to that information and gives us a little bit of that intent. Next, we have improvements around the addition of drawing tree columns. So adding those in is a new option. And around that, being able to support, or be able to sort the drawing tree by view models and parent views. So building out that drawing tree exactly how you like. Okay, moving on, we have improvements to removing hidden lines. So if you want to view or you want to remove some of those lines, so it's much easier to do now and helps us to build out those views. And we can now move the arrow with the name with these particular ones, right? So if you can kind of link the two, whenever you move the name around, you can have the arrows going to follow, or you can unlink it so you can kind of move them two separately. And then we have the ability to add multiple leads. This is the option where you can have multiple, you can have normal, tangent leaders, all coming off of one common annotation. That's really helpful for GTOL symbols, really working with anything around this. It helps it to make it a bit clearer and exactly what it's referencing off of those. All right, moving on to a little bit more on dimensioning. We're able to align ordinate dimensions with a baseline. Now, this is something that you run into if you're working with the ANSI standard. So that's how they like to do it. So if we've built out these ordinate dimensions, go ahead and work with them with that baseline. It works really well and is very clean in defining those. You can control the length of intersected contours. So beyond just the intersection point, you can enable those intersection witness lines. And then we can have our child view identification. So very easy to see where drawings go to. It's especially useful if you're working with kind of multi-page drawings, or again, even if you were maybe the one that you weren't the one that created the drawing. It's very helpful for keeping it all straight and understanding exactly what it's referencing and where it goes to. Continue to make improvements around GTOLs. So now we have additional indicator values, things like intersection or collection planes for angularity. In that case, it's working for the ISO standard. We have options for controlling the gap between our GTOL and the indicator frame. So depending on the standard that you're working with, if you're working with ISO 1101 2012 or 2017, you can have different options for that potential gap size. And around the standards, as they keep getting released, Creo is going to keep evolving right along with them. So now we've included support for both ISO 111 2017 and ASME Y 14.5 2018. And finally here, we have some options for the alignment of spacing when it comes to GTOLs, depending on how you want those GTOLs to align on the left, on the right. That's all done keeping up with those standards. I've also added some new symbols to the symbol palette, particularly the angularity symbol for the intersection plane. We have a runout symbol for the direction feature, and also a symmetry symbol for a collection plane. So if you work with any of those, nice added feature there. And finally, we've updated the parser for the syntax checker. Again, taking into account all those new standards, making sure it all works. So that's something that has really been a big focus here in Creo, is being able to do that type of detailing work and keeping up with all those standards as they keep being released. And Render Studio here is another area that's really had a few new options included there as well. So the first thing is the ability to pause and resume during the rendering. Normally, whenever you're in that mode, it's constantly running by default. But if you know you're going to need to make some changes, or just simply don't want it to be running for a minute, simply just pause the render, give the computer a break while you need to go do a couple things, and then you can simply play it again. So nice option there. We can also now render the mannequin vision window. So that's essentially taking whatever this mannequin can see, or it might be different types of humans or just different types of viewers where this is what they're seeing. We can actually render that view to get some really nice shots. That's a nice use case there. And also have the option to define a custom floor plane for the render. So it allows you to flip the model, change where the shadows and the reflections are going to appear. Now you have that added level of customization. It makes it really easy to do. And we also had some improvements in the world of augmented reality in Creo, where we're actually, if you haven't worked with that, that's where we're viewing these models as augmented reality experiences. So you can create these models, build them out, and then share them out with either your team or suppliers or just customers to see exactly what you've been working on. And you can do that for design reviews, even just showing off a customer, say, hey, do you like this part? Do you like this feature? And they can give you real-time feedback without you having to send the part over, them have the right CAD software. You don't have to do that. You simply just share this off and they can view this up as an augmented reality experience right on top of their desk. So that's really useful. And we're building this out more and more. So now we've included the ability to publish combined states as part of that experience. So that combined state can include exploded views, sections, different appearances. So that can all be included now as part of that AR or augmented reality experience. With those different states, the user can switch between each of those. So very quickly and easily switch from one view to the next. And you have these different view options when you're publishing out over to Vuforia View. Vuforia View is our free to download, free to use application, what we're using to pull up and view these augmented reality experiences. So that's a quick look into there. And then finally here, I'd like to briefly discuss a little bit of the improvements to the easy tolerance analysis tool in Creo, formerly known as tolerance analysis extension. If you've ever worked with this, it's just new naming for it. It's still working exactly the same way as before, but still going forward, we're making enhancements to it. And if you've never worked with it before, in general, it's a one-dimensional tolerance stack-up analysis tool. This is powered by one of our partners, Sigmetrics. And this is allowing us to perform these tolerance analysis over on our Creo assemblies. And this is something that you, right from the design, Creo design, it works with our annotations, our dimensions, our tolerances, GD&T information. And as you go through and make changes, have all those changes propagated to update the analysis data that we're doing here in the easy tolerance analysis. And with this change, we've done a lot to update the look and the feel of the tool, made it even easier and faster to do these type of dimensional stackups. And around that, lastly, we can define multiple stack-up analysis per model. We can evaluate many of the different impacts from these studies to look at things like statistical results, defects, worst case scenarios, RSS, and even which annotations have the highest contribution. So it allows you to go through and see, okay, maybe I need to tighten up a tolerance in a particular area, depending on what type of manufacturing processes they use. All right, and so that is our general look through a lot of the different enhancements. Again, you probably don't work with every single one of those, maybe just a couple of them or one or two, or maybe you do work with a lot of them, but really wanted to touch on the general overview around that. And what I'd like to do now is go through a quick demonstration working with the flow analysis tool in the context of Creo simulation line. So this is going to not only show what really the updated appearance of Creo looks like and how we function, use things like quick windowing and that sort of thing, but really showing a glimpse into how we use Creo Simulation Live and doing this type of analysis, and not as something as the expert analyst. It's not something that only that guru is able to work with. This is something that we can work with. It's just me, Joe, average day-to-day designer, can actually get some really good use out of this type of design process working with CSL. So we'll switch over to that here now. And so for our demonstration of that flow analysis, we're going to be working on a model for a muffler off of a motorcycle assembly. So this part actually came off of one of our customers' data sets from Royal Enfield. So this is the muffler off of one of their data sets. We want to go through and simulate some of the flow that's happening within this system. So we can take a section view to see kind of what we're working with here. And there's definitely a lot of great geometry to start, and we can go through and utilize here. So we can kind of start to make changes as to that geometry as we go forward here. If we want to start into it, we'll simply go up to the top, click to add our simulation, and we can see some of the different options here. So it's again right in the same UI, right in the same modeling environment we're used to. Simply go right up to the top and define the type of study you want to do. So this could be structural simulation, thermal, modal. In this case, we want to do a fluid simulation study. And with that fluid simulation study, there's a couple of things that we have the ability to go through and define to really start to look into how this part is functioning. So the first thing that we'll define is our fluid domain. This is the volume of space that our fluid flow is going to be contained within. To do that, we'll simply start here by defining what our inlet is right at the front, swap around to the back to define our outlets, and we can see that the system automatically builds out that internal volume for a model. And if we like it and accept it, that's going to appear now down in our model tree, something that I can go back to and make changes to later on, but I'm pretty happy for now. And what I can define from there next is the fluid material that I'd like to analyze. So in my case here, I know that carbon dioxide is going to be a very close approximation for what's going to be coming out of my motorcycle exhaust. So go ahead and select that. And then next, I'll set up my fluid flow velocity for my muffler. Essentially, how fast is this going to be coming in from my motor? Specify the surface I want to work with, and set the direction and the magnitudes here in my options. So I can do it as type in value, or I can do it like I did earlier, or like I mentioned during the presentation, just simply select on the surface and it defines that direction for us. All right, so now that I have that flow velocity set up, I can also set some thermal conditions. Maybe if we have a prescribed temperature at that inlet, we can set the value, set the unit. It's really whatever type of regular operating temperature might be around that motorcycle exhaust. Cool. So I'm pretty happy with those initial conditions around the inlet. So next I can define the outlet pressure for my muffler. I move around here to that back end. In my case, I'm just simply going to set that to 0, essentially just outside air. And with that, I'm pretty much ready to jump into the study. And one thing that we do have the ability to do is set really the quality that we want to run, where we can keep it all the way to the left for the highest speed. We can keep it all the way to the right for the highest accuracy, or maybe keep it somewhere in between. In this case, we want to have it be at the highest accuracy. And with that, we're ready to go ahead and click to simulate. You can see essentially as soon as I click to run the simulation, we're getting results back. It's really that fast. I have the ability to change things around over in my legend. If I only want to see the velocity within a particular range, do that composite view. I also have different display options that I can choose from, maybe to visualize the flow of individual particles. And with that, even more options for the particle to change the size, the transparency. It's really getting this looking the way that I want. Helps me to understand exactly how the flow is working, depending on how I set my model up. Okay, those particles are one really good way to analyze the flow. We can also use other ones, looking at, say, our direction field. What that direction field does is act as a cut plane, so I can use that to see the direction everything's going in. I have the ability to take that cut plane, move it around to different parts of the model. I can pull up our dragger tool here and change that around. Kind of see the direction that my fluid is moving based on how I defined it. Really helps me to interrogate certain areas, even type in specific values if I want to see exactly, roof at the edge. We can see what that looks like. And so as we can see, there's a lot of different ways to visualize those results. But we can also start to analyze and start to build off of that too. Starting first here, we have our live simulation probe. What this does is it allows me to see different values in my model. So if we want to check out what our maximum velocity is going to be down at our outlet, we can kind of see how that changes over the course of our flow. Along with that, we can see a graph of how those values are changing. Really helps us to see what's happening at that outlet. And so we have other options to view the pressure, temperature, vortices. Now, these are all things that we can start to design around and actually build off of. And one of the best ways that we do that here in Creo is with the use of the design exploration extension. If you haven't worked with this before, this is our tool in Creo for trying out new designs, new iterations, branching off of existing designs. And instead of how we would normally do it by making lots of copies and doing save as all the time, we can work right within this one exploration session. We start into the session with a pre-modified version of the model. As we go through and start to make changes, instead of saving off different copies, we simply just build out checkpoints at any place we might want to come back to or branch off of. In this case, we have these internal baffles. Well, what's going to happen if we take a couple of them and make them longer, increase the length of each of those? So even though we're in this design exploration session, we have the flow analysis running all at the same time, we're still able to do this standard sort of CAD Creo work that we're used to. The difference is now is as soon as we make that change, we're getting instant insight into what that does to our analysis. I can go back now and see what that does to the particle flow, see where the velocity is increasing or decreasing. We can check out the graph for that velocity. And this isn't something that I send off to the analysts and hope to get results back by the end of the week. We make the changes, you immediately get to see what that result is. If I'm happy with that change, I can make a checkpoint showing that I increased the length of the pipes there. So we can see that DEX or design exploration extension is keeping track of all those changes that I'm making. What that allows me to do is keep making changes to the design. And maybe in a past design that I worked with, I built these pipes out of these baffles with holes in them. Well, I'm going to see how this design would work if I activated those holes. So I can activate those from the model tree and see exactly what that does to our flow. And we pretty much immediately see we have a very different type of flow down by our outlet. We can check the probe there. We can pull up the graph to see some of those values that we're getting. So we can clearly see that we started to increase that outlet velocity. But we can check out other values as well. So switch to that composite view, see how the velocity is moving through those pipes. Also check out the pressure. Kind of seems like we really smoothed out the pressure flows or the pressure drops throughout that model. Might be useful in order to see exactly where we have max values throughout the model, kind of have those move to the front of our view here. And then similar to how we did with the direction field, we can also take kind of true section views at different points of the model to see what's happening at different parts. So move around to the back here, kind of take a closer look at the flow going through those holes. We can see looking at that direction field that it's almost even reversed the flow around those holes in those baffles. So I'm definitely happy with the changes I made so far. And if I want to capture that design intent, just go right back, make a checkpoint to show where I was when I made those changes for the holes. So now that's something that I can check back on, switch between different checkpoints. It's really starting to capture the work that I've done throughout this design. I'm pretty happy with where we're at towards the outlet, but now what I want to do is actually kind of move my direct my attention more towards the beginning of the flow. And see, right now we basically have a solid cylinder with a bunch of pipes going through it, but I want to start to change up that design. What we can do first, clear out the feature that I have right now, and instead start with more of a clean slate that I can begin to add to. And what we can do here also is just use one of our multi-body commands. So very quickly, just remove that body from the model. And with that area now cleared out, we can begin to build out some new geometry in there. And what I actually want to do is add in a lattice feature here to regulate the flow through our channel. So this could be something that we're planning on creating using additive manufacturing. And to start, there's really a lot of options when building this out. And the first thing that we'll do is specifying the surfaces or the area that we're going to use to define where those lattices should be placed within. This is what we call a lattice region. So we'll simply just go through, select on any of those edges to define the region. And latticing, you may have kind of noticed, is a feature that we've had a lot of focus on over the past couple of releases of Creo. It really gives us the ability to create some awesome, robust, complex structures that have a lot of different uses, especially in the world of 3D printing. And once we have that defined, we can go through and work with the new coordinate system, say where that first cell should be located, and then we can define what the cell shape should be. So we have options there, lots of 3D shapes or kind of like we're doing here with more of a 2.5D shape and more of a hexagon. That one's big, so we can scale it down and change other parameters around it for whatever we need. So if it's a little bit thin, make that wall thickness a little bit thicker. Visualize it here if we want to see what that would look like before we go ahead and accept it. But I'm pretty happy with it, so we'll accept those changes. Again, even though I made a fairly significant change there, the analysis is already updated. And then we can go through and actually analyze the results. And we can change the display state, change the result type. Maybe if we wanted to check out how our pressure changed around those lattices, we could go through here and do that as well. Okay. On top of that, we can check out around the velocity at the outlet of my motor. See if we want to pull up the simulation probe, check out the graph for that if we like to, see any of those values around here. So let's check out maybe down by our outlet, are we getting spikes or where is it starting to settle out around? All right, and so once I've had the chance to review those results, because I'm in Dex, build out a checkpoint. Shows exactly where I was when I made those changes. And if I'm happy with where the design's at, I can choose to accept any of those. And then now all those changes are applied to that parametric model. And even though the design exploration is a great tool, I don't have to be in Dex to make changes to the model. This could be a day or two later, and maybe someone on my design team is saying, hey, Paul, we actually need to decrease the outlet of that velocity. Well, to decrease that outlet velocity, maybe a good place to start is around the diameter. Probably want to increase that a little bit. Spread that out. And once I make that change, just simply regenerate the model, and the analysis updates right along with it. I can go back, check the probe, see the values that I'm getting for the velocity. Definitely dropped down a bit. We're now seeing around 250, 240. And that's really the idea with flow analysis in CSL. Make any of the changes you want. Try this, try that, try anything. We don't want to limit at all the amount of creativity that you can have in your design by having to wait around for some of those results to come back from the analyst. We simply just build out the model how we like and immediately get that insight back. Right. And so that's essentially good for our overview there of really a lot of the different topics and then taking a little bit of a deeper dive into the flow analysis in CSL. So what I can do now is take any questions that we might have. I'll pass it back over and go from there.
Great. Thank you, Paul. I'm going to hold a few moments for questions like you said, and we appreciate you staying with us as we kind of run over a little bit. While we wait, I'd encourage you to visit tristar.com or call us after the session if you have any further questions that may not get answered right now. And we will also be sending a brief survey via email shortly after this presentation. We do appreciate if you can just fill it out. It's maybe 5 questions or just about future topics and how we did. So I'll just give it a moment here for anyone to throw some questions in here. We did have one very early on, Paul. Is Creo Simulation Live thermal and fluid analysis, is it based off of Creo Flow or is it using ANSYS?
No, yeah, it's a good question. So those are 2 different engines in and of themselves. So the CSL, thermal and flow, are based off of an ANSYS engine. It's off of that Discovery Live engine where each of them kind of uses their own solvers. And then the other tool that I was referencing was the Creo Flow Analysis, or CFA. That's by one of our partners, Simerix. And so that's a separate engine now. And that's responsible for everything you have in those. So kind of separate in those senses and really targeted towards different use cases. Our CSL is more for throughout the design process and as you're going through and making changes, being able to visualize that. And then CFA kind of gives you more higher end capabilities where if you actually wanted to do more of the validation step analysis where you built out the tools or you built out the models or the assemblies a little bit more, you could go through and really validate on the decisions you made and check into whatever values you wanted to there.
Perfect. We did get another question here. Is there somewhere where we can find, or basically, is there anywhere we can find like a review of the features that are included in the standard installation versus ones that require extensions?
Yeah, I think there might be some resources available on the PTC website that go over exactly what comes with the base capabilities of Creo versus what comes in the extensions. But I don't have it off the top of my head right now or anything, but maybe we could look into that a little bit after the call and see where we could direct you to get that information.
Perfect. Yeah, so I'll do a little research and we can actually email that out to you. And just hold another moment or so for more questions. All right, it does look like that is it. So thank you again, everyone, for joining us today. And thank you, Paul, for the presentation.
Yep, no problem. Have a good day, everybody. I guess
Yeah,
thank you for sticking around and checking out everything that's new in Creo 7. Definitely a lot to be excited about. I know I am.
excellent. So stay safe out there and enjoy the rest of your week, everyone.
Yep, have a good one.